Number 5 asks you to both complete and balance the reaction and do calculations. This reaction says when 0.68 grams of aluminum metal reacts with water. Aluminum is just Al, and water is H2O, though I'll address that in a second. I have something with one part reacting with something with two parts, making this a single displacement reaction. When you have water in a single displacement reaction, you need to envision it as hydrogen hydroxide rather than as H2O, because the ions that we have in the water that we need to be interested in are H and OH. So we have H plus and OH minus, and that's going to matter when I decide what the aluminum bonds to. The aluminum is going to become a positive 3 charge. And if the Al is a plus 3, it's going to bind to the OH, which is a minus 1, giving me AlOH3. And now I have hydrogen alone. Is hydrogen diatomic? Yes, it is. This reaction to balance is a little bit weird. I have 3 OHs and 2 Hs, and so this isn't going to come out as anything nice with the aluminum with the water. And if you try to go down a path here, you're going to find yourself that might end up in a dead end. When that happens, a piece of advice is to go back and put a 2 in front of the first thing and try again. Now that I have a 2 in front of the aluminum, I put a 2 here. Now this gives me 6 hydroxides on the right-hand side. I'm envisioning this part as my hydroxide. So I'll put a 6 there. Now this gives me 6 Hs. A 3 there will give me 6 Hs. Now I'm ready to do the problem. I have 0.68 grams of Al. 0.68 equals moles times the molecular weight of aluminum, which is 27. 0.68 divided by 27 gives me 0.0252 moles of Al. I want to know how many grams of hydrogen gas form. So the H2 is my want, and the Al is my given. So I'm doing my mole ratio of want over given is a ratio of 3 to 2. So multiply by 3 over 2 gives me 0.0378 moles of H2 forming. I now need to do grams equals moles times molecular weight. The molecular weight of H2 is 2 because there's 2 H's, giving me an answer of 0.076 grams of hydrogen.